All right, these are the notes for lesson 1.3 on midpoint and distance formulas. Go ahead and put your name. And let's begin. Okay, so the warm-up. It says that the cities shown on the map lie approximately in a straight line. Find the distance from Sacramento, California to San Bernardino, California. Okay, so it's asking for the total distance from this point to this point. Now we know the distance between Sacramento and Fresno, and then from Fresno to San Bernardino. So we can therefore calculate the distance between Sacramento and San Bernardino. All we need to know is that 158 miles plus 230 miles is going to be equal to the distance. Okay? And 158 plus 230 will give us 388 miles. That is the total distance traveled, okay? Pretty simple. Now this, the tricky part was what it's called. It's called the segment addition postulate. That is what we used to solve this problem. Okay, moving on. So now we are going to start by talking about a midpoint. A midpoint is a point that divides the segment into two congruent segments. So from this image, okay, we are looking right here. We have from J to K, we have a midpoint M. We know it's the midpoint because the distance here is 3 and the distance here is also 3. So it divides J and K into two equal parts, okay? That's how we know that it is a midpoint. Okay, something that you guys should know is in our course, it will never assume that you guys should know that it lies in the middle of a segment. It will always either tell you numbers, will always tell you numbers, or will have congruence marks. An example would be if we had A divided by B and C, and they stuck a little, or let's do 2. If they had 2 dashes in between, that would mean that AB and BC are the same distance or the same length. Therefore, B is the midpoint, okay? If M is the midpoint of JK, then JM, which is the left side between J and M, is equivalent to M and K. And so are the line segments. The line segments are considered congruent, all right? Okay, so next slide. A segment bisector. A point, line, ray, line segment, or plane that intersects the segment at its midpoint is called a segment bisector, okay? Go ahead and put a squiggly underneath segment, okay? One thing I want you to note, you cannot bisect a line, ray, or plane. Okay? Now let's think about that. We can bisect a segment, but we can't bisect a line, ray, or a plane. The reason is because all of them continue on forever. Here's a ray, here's a line, and our plane, even though it looks finite, continues on in each direction. Okay? So we need something finite in order to bisect it. All right, so let's look at the image that we have. So we have the line CD is a segment bisector of AB. So the distance between A and M is congruent with the distance between M and B. All right, so one thing that you should note is that M is the midpoint of AB. All right. So segment bisector is basically a fancy word for a line or array or a point or a line segment or a plane that goes through the midpoint. All right, moving on. So example 1, in the skateboard design below, VW, let's go ahead and add, or let's go ahead and circle VW. Okay. VW bisects XY at point T, and XT is 39.9 centimeters. Okay. Find XY. So that would be find from X all the way to Y. So in order to find XY, we have to break it up into two parts. First, X to T, and then from T to Y. Now, it told us that VW, which intersects at T, it bisects it. That means that it intersects at the midpoint. And you can tell that as well because there's two of these red congruence symbols, meaning that this side, X to T, is the same length as T to Y, okay? So when we are writing this, XY equals 39.9 plus 39.9. So XY is going to be equal to 79.8. And that is centimeters. Okay. All right, example 2. Point M is the midpoint of VW. Find the length of VM. Okay, so we know that 4x minus 1 is going to be equivalent to 3x plus 3. How do we know that? Because M is the midpoint. So each side or each section of this line segment is going to be equivalent, okay? So what we can do is we can just set them equal to each other. All right, so let's go ahead and do that. Let's write 4x minus 1 equal to 3x plus 3. Okay, so now what we're going to do is let's move all the x terms to the left side and let's move all the non-x terms to the right side. Okay, so in order to move the x terms from the right, we are going to subtract 3x from both sides. Okay, so now we're left with 4x minus 3x minus 1 equals 3, because this is going to cancel. Next, we want to add 1 to both sides. And that will give us 4x minus 3x equals 3 plus 1, because these are going to cancel. So 4x minus 3x becomes x, just 1x, positive 1x, and this becomes 4. So if we know x is 4, it's asking us to find the length of v to m, okay? So in order to find that, we need to now plug in x equals 4 into this portion of the equation. So 4 times 4 minus 1, which will give us 16 minus 1, which is 15. So we can say that Vm equals 15. All right? Moving on. Okay, so the midpoint formula. So sometimes it's not going to tell you where the midpoint is, and you are going to have to find it on your own. We have a formula for that, okay? So this formula down here, I want you guys to box it in, highlight it, do whatever you have to, because this is a very important formula. Okay? So given any 2 points, you can find the midpoint by plugging in those coordinates into this formula right here. So let's take a look at the image that we have, okay? It looks really complicated, but I'll explain everything, okay? So let's look at point A, and let's look at point B. So it's saying that point A over on the y-axis corresponds to y1. It's saying that point B over on the y-axis corresponds to y2. Now the midpoint formula's y-coordinate is y1 plus y2 divided by 2. Okay? Now let's look at x. A's coordinate for x is x1. B's coordinate for x is x2. And our midpoint formula for x is x1 plus x2 divided by 2. So you're basically just finding the average of each coordinate, and then you are making your own coordinate. Okay? And we will do examples, so don't worry. All right, next. So the endpoints of RS are R at 1, -3, and S at 4, 2. Find the coordinates of the midpoint M. Okay? So we've got S is 4, 2, R is 1, -3. Let's go ahead and find the midpoint. Remember, the midpoint formula is x1 plus x2 over 2 and y1 plus y2 over 2. Now, we can label either S as the S coordinates as x1 or the R coordinates as x1 and y1. So it doesn't matter which way you do it. I'm going to label this as x1, y1, x2, y2. Okay? So our x1 is 4 plus x2 is 1 divided by 2. And our y1 is 2 plus, and our y2 is -3 over 2. Okay? So now our midpoint is 4 plus 1, which is 5 over 2, and 2 plus -3, which is -1 over 2. Okay? And if we look at our image, that should make sense. 5 over 2 is just over 2, so around 2.5. That looks good. And then we were going down a half, which makes perfect sense. That's where our M is located. Okay? All right, next one. The midpoint of JK is M at 2, 1, and one endpoint is J, which is at 1, 4. Find the coordinates of endpoint K. Interesting. Okay, so now it tells us both the endpoint, it tells us the midpoint, and now it wants us to find the coordinates of K, which is the other endpoint. Okay, so how are we going to do this? Let's use our midpoint formula. Okay. So x1 plus x2 over 2 and y1 plus y2 over 2. Now, we already know the midpoint. It's 2, 1, right? So what we have to do is we have to take x1 plus x2 over 2 and set it equal to the x coordinate for the midpoint, which is 2. Okay? That's this one right here. Now, why do we do that? Because we are going to know what x1 and y1 are, and then we can solve for x2 and y2, the second coordinate. So let's go ahead and get that started. x1 is 1 plus x2 over 2 equals 2. We can multiply both sides by 2. I will get rid of this. This will become 4. So then we're going to have 1 plus x2 equals 4. We can subtract 1 from both sides, and we are left with x2 equals 4 minus 1 is 3. So that is the first coordinate. So we can say K is going to be at 3, comma, and now we are searching for that y2 coordinate, okay? All right, let's go ahead and start it out. y1 plus y2 over 2 is going to be equal to, our y coordinate for M is 1. Okay? So now, we know what y1 is because it gave it to us from J. It's 4, okay? So now we're going to plug in 4 plus y2 over 2 equals 1. You multiply both sides by 2. These are going to cancel. 4 plus y2 equals 2. Next thing we're going to do is we're going to take away this 4 from both sides. That way all we're left with is y2 equals 2 minus 4 is negative. That's switched on me. So now we have the y2 coordinate, which is negative 2, which gives us what K, the coordinates of K are. Okay? That one was a little bit different, but now that we've seen it, we know exactly how to do it. 2. Oops. All right, the distance formula. So if you are given any 2 points on a coordinate plane, you should be able to find the distance between them. And we use this formula down here, okay? So you're taking x2 minus x1 squared plus y2 minus y1 squared. And then you take the square root of that whole thing, and you will get the distance formula, or the distance between the 2 points, okay? All right, and we are going to do some examples with that. To remember it is the square root. So it says find the distance between the 2 points. Okay, so we've got A and B, and then C and D. For the first one, first thing I want you guys to do is label either x1, y1, x2, and y2. Okay, that way we do not get confused. So the formula, if you need to go back, of x2, 7, minus x1, 13, squared, plus y2, which is 10, minus y1, which is 2, squared, okay? This is going to give us, when we start to solve this, 7 minus 13 is negative 6 squared, plus 10 minus 2 is 8 squared, okay? So now we can say that this is equal to 6, negative 6 squared is negative 6 times negative 6. That will give us a positive 36, plus 8 times 8 is 64. Now 36 plus 64 is going to give us 100, and the square root of 100 is 10. So our distance between these 2 points is 10 units, okay? All right, let's do the same thing for C. Let's label C our x1, and oops, should be y1, and then D will be our x2, y2, okay? So again, start off with the square root of 4 minus 2 squared plus negative 1 minus 3 squared. From here, 4 minus 2 is just 2 squared, plus negative 1 minus 3 is negative 4 squared. Two squared is 4. Negative 4 squared is 16. 4 plus 16 is the square root of 20. And the square root of 20 is not a nice number. Let's see if we can figure that one out. It is 4.472, and that is our answer, okay? All right, next one. And that was our lesson, okay? So go ahead and get started on the homework, and email me if you have any questions. Thanks for listening as always, and good luck, you guys.